after a famous play called Waiting for Godot, which is about a bloke called Godot who not only isn't there, but never actually turns up. And so it's really a play on the fact that we don't know whether we're going to get a Zika outbreak, particularly in North Queensland. But the issue is that we're certainly not waiting for it, as you'll see from this lecture. There on the front, of course, is a picture of Aedes aegypti, the vector mosquito. So I think there's all sorts of stuff that is interesting for registrars here. The key one being that topical issues come up in exams. But beyond that, we're talking about emerging diseases, vector-borne diseases, issues around causation and dealing with uncertainty when we're responding to disease threats, issues around health promotion and mobilisation, some of the things about the surveillance systems and the definitions that are being used to try and detect this disease, and of course all of the business about congenital infections, also pandemics and disaster planning, and also a few things about neglect, neglect of North Queensland and other developing countries, as I put it. So hopefully those issues will come up, but if they don't, then you're welcome to ask. So these are the topics that I covered in the earlier version of this talk, which I've now edited, talking about, what is Zika? Does it cause birth defects? Will it come to North Queensland, where we have the vector in large numbers? And what could we do to stop it? All of the things about travel advice, sex and pregnancy, some issues around case finding and surveillance, and what we need to do around prevention. I suppose the first question is, why did Zika emerge from the forests of Uganda in 1947? And why has it suddenly seemed to have changed its behaviour and become not only endemic or epidemic in Latin America, but also causing severe birth defects almost certainly now? We've now got two strains of the virus, an African strain and an Asian or Pacific strain that is now in Latin America that seems to be doing all the damage. I guess the answer to my question about why did it emerge is because it could. We know that there are lots of obscure viruses, including obscure flaviviruses. Here in Australia, for example, we've got a number that can pop up on your serology: Elfie, Stratford, Kookaburra, Edge Hill, not to mention Murray Valley encephalitis, and Kunjun, which is the local variant of West Nile. You'll hear it called West Nile. And of course, overseas, yellow fever and Japanese encephalitis, not all of which are transmitted by the same vectors, but all flaviviruses that can confuse your serology. So when we think about emerging diseases, I like to think about the ecological niches or the modes of transmission that are permanently a threat to humans. The first one, of course, would be fecal-oral, including food and waterborne diseases. Then we've got respiratory-borne diseases. We've got sexually transmitted infections. And finally, we've got vector-borne diseases. And all of those are routes of infection from person to person. We find that even if we conquer one disease with a drug or a vaccine, something else inevitably pops up, particularly when humans have such strong contact with animals. We're finding that these things go on. Now, if you're looking at that map about the spread of the virus, before it got to Latin America, we know very little because this was such a unimportant, non-serious virus as far as we knew. And in particular, we know very little about what happened in Asia, mainland Asia, Southeast Asia, our tourism and trading partners, because not only did they not have the diagnostics, it was very difficult to tell the difference between this and other febrile diseases, including dengue. And we simply don't know whether there has been massive epidemics, and we don't know whether there's been ongoing or sporadic transmission since then, except in a few cases. Equally, we don't know whether they've had birth defects because they haven't had the surveillance systems in place to really pick up a change. And the first well-described outbreak was on the American-owned island of Yap in 2007, and then some more information about what happened in French Polynesia. So we know that Zika is a single-stranded RNA flavivirus. As I said, there are lots of them. This causes a very mild illness. Probably 80% of cases are asymptomatic, and therefore more than 90% of cases in Australia will probably never be detected, because if they're mild, nobody's going to be go to the doctor. Probably what differentiates this a lot from some of the other flavies is the rash. You can get a rash with dengue, of course. Maculopapular, itchy in people who are not particularly sick. And of course, fever, arthralgia. You can get swelling of the joints, headaches, conjunctivitis, tiredness, weakness, which is pretty non-specific and similar to other arboviruses. But there's a huge differential diagnosis, including things like ordinary influenza. So, as with other arboviral infections, we think that people fight off the disease within about a week and become immune probably for life, or at least for a very long period. But we don't know that for sure. And we have no treatment or vaccine, although lots of vaccines are being developed. One of the questions you should think about is, how would a vaccine be used? And who would a live vaccine or a dead vaccine be used on? We know that a live vaccine couldn't be used in pregnant women without some risk. And we know that a dead vaccine might reduce the naive population size, but as we've seen with some other diseases, that could simply move the age of infection on until people are a bit older, like when they're in the reproductive age group. So there are dangers that vaccines could actually shift the peak age of occurrence from an endemic situation in young children to something where people only get their immunity later on while they're pregnant, which would be a disaster. So we have to think very carefully about whether the vaccine could be used adequately, and even if it was affordable, given the huge costs these days of making these things. We do have examples of flavivirus vaccines, of course. We've got yellow fever, Japanese encephalitis, and more recently in some countries they've just approved a dengue vaccine. So if you look at some of these phylogenetic family trees, you can see top right, Zika in the African and the Asian strains, closely related to dengue, closely related to other viruses like Murray Valley, etc. I talk about it in terms of transmission as being dengue 6, or if there's a dengue 5, which is a rare thing, meaning that it probably transmits in a very similar way to dengue. It's also not unusual among these viruses to have something called neural tropism. If you're wondering why, it probably relates to something about the evolution of parasites. Normally infectious diseases and parasites, it's not in their interest to kill the host, and over time in the human population they tend to evolve to something which is milder, so it can spread for a longer period. But that rule doesn't always apply to vector-borne diseases like falciparum malaria, because it may need to disable the host quite badly so that they're unable to defend themselves against mosquito bites, and therefore the evolution of virulence in vector-borne diseases does not always go towards milder disease. Of course, it's probably purely an accident that the main neural tropism is to the fetus, because that is of no advantage to the virus of itself. So the other important thing about vector-borne diseases, particularly mosquito-borne, is a thing called species sanitation. It is not good enough to say get rid of mosquitoes or avoid mosquitoes. You have to look very, very carefully at a wide diversity of mosquito habitats and behaviours and focus on the ones which are the main vectors. So Aedes aegypti is actually quite a special mosquito. It's very different in some ways to other mosquitoes. It's often called the cockroach because it's highly adapted to human habitations, only really bites humans, only really breeds around humans, and tries to get into people's houses. These things are quiet and shy. You may not even notice them. They don't fly very far. They breed in and around your house. They hide in dark surfaces, under cupboards, behind curtains, etc., in houses. In other words, if you had to invent a mosquito that was a human specialist, this is what you would do. Now, extrinsic incubation period means the time it takes for the mosquito, and it's always the adult females who drink blood, to pick up the virus and then become infective themselves to other people. In other words, they have to develop the the virus or the disease themselves. It doesn't seem to harm them, and it takes maybe 8 to 12 days. A little bit of uncertainty or range about that, depending on climate and other factors. And we think that the female is infective for its life after it picks up the virus. So it can spread the virus every time it bites somebody after that, and they are prolific biters of humans. They'll often bite several people at the same time in a house before they lay a batch of eggs. So the whole question, at least in the last couple of months, is does it cause birth defects? And I've actually sent you a paper on this topic, which is really interesting read. It talks about the Bradford-Hill criteria for causation, and also another table that I didn't know about, which is Shepard's criteria for proof of teratogenicity, which is a little bit more specific to congenital infections. As you know, there are other congenital infections denoted by torches, toxo, CMV, syphilis, etc., etc., rubella, of course. So one of the problems we had early on is that there was just reports of increased microcephaly. But microcephaly is not all or nothing. It's really depends on where you want to put your cutoff in terms of measurement of cranial size in relation to the body. So it's a measurement, not a syndrome, and therefore, depending on where your cutoff lies, you can get some babies which have not very small heads and who don't have neurological problems, all the way to very severe cases with very tiny heads. So initially, people were saying, well, why is this just happening in northeast Brazil and not elsewhere? Is there something else about northeast Brazil that is going on? And so we were talking about poverty, pesticides. Some people were blaming larvicides that are used against mosquitoes with very little basis, in fact. Or is there some other factor? And in fact, one of the birth cohorts showed that there was a high rate of microcephaly even before the Zika outbreak. But however, there was a steep rise in the severe cases afterwards. So a lot of uncertainty at first, but I think that the evidence has become stronger and stronger. Certainly the consistency involved in finding very similar things from French Polynesia. This is all basically retrospective data. But you find that most places that have had Zika outbreaks, the numbers were too small or the surveillance systems were too weak to detect Zika and or the damaged fetuses. We know that it's a whole spectrum of damage that we're talking about now. It's not just microcephaly, it's miscarriages, stillbirths, brain calcifications, eye damage, a whole variety of disorders that we may not know all about yet. There could be some very subtle things that are going to come out in cohort studies of children as we go forward. So one of the strongest pieces of evidence, apart from now quite a strong association in time and place between the outbreaks and these birth defects, is of course that we've been able to do postmortems or blood tests or tissue tests on these fetuses, and we find quite marked infections with this virus, and we know that the virus is attacking nerve cells. We don't have animal models. We think that it used to spread in monkeys, but that's not important virtually anywhere anymore. It's basically jumped over to humans. And so World Health is expected to confirm this, as commentators in CDC have. So in terms of those Bradford-Hill criteria, strength of association, consistency, specificity, meaning we've got a well-known syndrome that seems to be, doesn't vary that much from one case to another. Temporality, meaning that in general it's the infection that can be shown to precede the effect. Plausibility, we know of other viruses that do this, particularly in the first trimester. Coherence, and consistency again. We don't have experimental evidence because it would be unethical to infect human pregnant women. So in other words, it meets a lot of those criteria. I think the important thing to remember here, guys, is that causation is never proven, just as hypotheses in science are never finally proven. At the end of the day, we're using those criteria to form opinions and build evidence. And so here in North Queensland, we could not afford to wait while CDC or World Health Organization made up their own mind. We had to make up our own mind, and very early we worked on the assumption that this thing was causing birth defects. Of course, since then, there's been another association with Guillain-Barré syndrome. Guillain-Barré is a paralysing autoimmune type of disorder that happens soon after an infectious disease, notably things like Campylobacter, and probably at rates similar to Campylobacter. In other words, still relatively rare. And there have also been encephalitis or meningoencephalitis cases, as with other flaviviruses. Again, not unexpected. So I think we're getting to the point where we can say that we've proved, or we've got strong enough evidence to say that this is a causal association. Difficult to really work out the level of risk so far. We think the background rates are about 5 per 100,000 births. But of course, there are other things happening to these kids, as I mentioned: growth retardation, calcifications in the brain, stillbirths. And there's a lot that we don't know. We don't know, for example, if the woman has a very mild infection herself, does that change the risk of damage to the fetus, or is it an independent problem? We're not sure about the stage of pregnancy. By way of analogy, early on we were saying, look, it's probably a first trimester problem, but I'll show you now that it seems to be happening at any trimester. We don't know about cofactors. One of the things with severe dengue is that previous antibody to previous dengue serotype infections can make the infection worse. And so whether there are toxic, nutritional, or antibody cofactors operating in Brazil, we still don't know. We have detected Zika virus in breast milk, but it's unlikely to counterbalance the known benefits of breastfeeding children. And really, we don't know much about newborns or very young children getting Zika. We haven't had reports of them being harmed, but there could be subtle things going on. So we still need to do a lot more work, probably cohort studies, to really get some idea as to the total burden of disease. A lot of that information is coming from a cohort in Rio de Janeiro that was actually set up for dengue and was just happened to be at the right place. They recruited women who had rash in the last 5 days. In other words, they did have symptoms, and they tested them by PCR. About 82% of them tested positive for Zika, and their acute infections varied from 5 to 38 weeks gestation. Most of the mothers had a very mild illness. 42 of them consented to fetal ultrasounds, and 12 out of 42, which is nearly 30%, which is quite striking, in those who were Zika positive, but none in Zika negative. And the abnormalities varied: 2 fetal deaths, 5 growth retardation and/or microcephaly, 7 with intracranial calcifications or other CNS problems, and 7 with abnormal amniotic volume or cord flow, suggesting placental insufficiency. So that's the bad news for now. The latest evidence that's coming out is suggesting this is not just a first trimester problem, but in fact, this is the graph showing the darkened ones are the abnormal findings, and they are graphed against the time of onset of the Zika infection. And you're finding that people are getting nasty results, including stillbirths and fetal deaths, even in the 2nd and 3rd trimesters. So this is very worrying and a little different to some of the other congenital infections, where they tend to get milder towards the end of pregnancy. So we've had to deal with all sorts of myths, particularly up here where it's a big concern for the local population. The media will report that because we've got the vector, therefore we will get Zika outbreaks, or that the virus is somehow here by magic. But of course, these mosquitoes are not born with the virus in them, or that the vector itself means we are a receptive area. There are lots of parts of Queensland with very small or intermittent detections of Aedes aegypti mosquitoes that have never had a dengue outbreak, and that's because the numbers are too small and the survival time of those mosquitoes is too short. As I said before, it's only really the elderly females that can survive one EIP to infect other people. And so really there are a lot of factors other than the presence of the vector which makes it likely that you're going to get sustained outbreaks. They also talk about the number of cases that have already occurred as if there still are. So they will say there are 18 cases of Zika in Queensland, when in fact those people were all imports and they got better. There's no Zika of them. They shouted that it was a global Zika emergency, when in fact the public health emergency of international concern was really about the birth defects, not necessarily Zika at that time. And then all sorts of speculation and overemphasis on some of the more obscure suggestions. We do know that sexual transmission seems to be more than we expected at first, but still a minor mode of transmission. Transfusion is very unlikely in Australia because of our blood protection programs, and even claims that somebody got Zika from a monkey in Bali, even though the fact that they couldn't exclude they'd been bitten by mosquitoes, which I thought was bizarre. So they were talking about all of Queensland, or central or southern Queensland, or far north Queensland instead of North Queensland, which is the correct area that we think is receptive given what we know about dengue in the last 20 years. And the Eliminate Dengue program, which is releasing resistant mosquitoes, is genetically modified, which it isn't. It's actually just carrying a natural bacterium. A lot of people expect us to do fogging, and I'll explain why that's the least useful method of controlling these mosquitoes, and also implying that every pregnant woman infected will get microcephaly. It may be 20 to 30%, remembering that that cohort was among people who were sick. We don't know what's happening in those who are infected but don't get symptoms. So one of the reasons why we don't do fogging is that it's an enormous amount of insecticide in the environment, relatively toxic to humans and others, and simply kills the mosquitoes that are flying around at the time. It's misdirected because the mosquitoes hiding inside buildings, which is what Aedes aegypti do, will not be affected. In fact, this is used in poor countries to show that they are doing something. It's got a lovely political effect, but it's almost useless in dengue control. So still a number of unknowns here. Can we quantify the risk of microcephaly and other birth defects, or even Guillain-Barré in adults? Are there other factors involved, as I've mentioned, nutritional or serological factors? And another really important unknown is, can asymptomatic humans transmit to mosquitoes? And that's going to be vital for our planning in North Queensland. How long are men able to transmit Zika virus? There are now several published reports. We've found the DNA, but not necessarily live virus, in semen for months. But that's an important distinction between what you can detect with PCR and what is actually working virus. We don't know how likely this is. There's been one report of male to male, but no reports of female to male transmission. So it seems to be one direction, but that would be remarkable if we had not only a new virus jumping from monkeys to humans, but then jumping from vector-borne to sexually transmitted. And I'm not convinced that's going to happen. And one of the other key unknowns is that outside of those countries where we are having known epidemics at the moment, there could be lots of other countries where it's either low-level endemic transmission, in other words, under the radar, or even sporadic cases. And as I say, we have no information from many of our closest neighbours, including PNG. We know the virus is there, so there is at least sporadic transmission. Given the assumption that there's lifelong transmission after infection, we would expect that this thing would go epidemic in a number of highly receptive countries for dengue, but then it would settle down to an endemic transmission or sporadic transmission pattern. And so what might happen in Latin America in coming years, and also the Pacific and Southeast Asia, is that this thing stays around but at lower levels and therefore lower risk of importation to some other countries. One of the other concerns is, of course, that we've got lots of other Aedes-type mosquitoes, Nodoscriptus, Vigilax, salt marsh, bush mosquitoes, where at least in vitro, in a laboratory, you can inject them with Zika virus and they will grow it in their bodies. But that's not the same as saying that they're effective vectors in vivo or in the field or in real life. So a lot of it depends on their biting behaviours and preferences. We know that Aedes aegypti is a human specialist and virtually only bites humans, and lots of them, whereas other mosquitoes will mainly bite birds or mammals and are out in the bush, and so even if they are able to grow the virus, it's unlikely that they would be important vectors. So It's still a proviso. We haven't finished that work for Australia, but the fact that we don't already have Zika outbreaks suggests that these things are not important human vectors. And of course, we don't have any other reservoir animals that we know of in Australia. So the key question for us in North Queensland is, if we get dengue outbreaks in North Queensland, could we get Zika? So we know that Aedes aegypti is the major vector, the dengue mosquito. It also carries yellow fever, chikungunya, etc. There's another vector in Latin America and the Torres Strait called Aedes albopictus, the Asian tiger. This one tends to live more outdoors and escape from houses. It breeds in the bush or small volumes of container water in the bush as well as around homes. Certainly present in the Torres Strait. The reason why we're working so hard to keep it out of mainland Australia, it doesn't mind cool weather and could probably go all the way to Melbourne, which would be very unfortunate. So most of the risk is in the wet seasons where Aedes aegypti numbers rocket, and we've got a completely non-immune population in Australia. We hope to keep it that way. But we've got direct flights between Cairns and Townsville, Bali, PNG, Manila, lots of other places. We've also got local communities of Brazilians and Pacific Islanders who could visit more often to those places and come back. And also there's a big military base in Townsville where we worry about military deployments and returnees. For example, people who've been helping with the cyclone in Fiji are just coming back now. The Army wrote to me and said, well, you know, is there a danger that they could sexually transmit to their wives? And I said, well, never mind sexual transmission. They could transmit it to their families by being bitten by mosquitoes around the house. And where we've been asking the military to rather bring people back through Brisbane or Darwin where we don't have these vectors, which we don't think they've done. Yeah. So really the reproductive rate, R0, depends a lot on the environment and the humans and not just the presence of the vector. So we think that there are lots of places where you could have a kind of fluke, local, single transmission which would not result in a sustained outbreak. But we do think this is probably possible in North Queensland where we've had some very large dengue fever outbreaks, and that's what we're working on. So if you look at the receptive area within Australia, the blue dots are places which have not had dengue outbreaks in the last 20 years, and the red dots are where we have had outbreaks, starting at Charters Towers and Townsville in the south and going all the way up to the Torres Strait Islands between us and Papua New Guinea. And overlapping that, I've just shown the approximate range or distribution of Aedes aegypti. It's a little bit misleading though, because Aedes aegypti does not live in the bush. It lives only in the urban areas within the shaded area, all right, and mostly in very small numbers. And so the more effective understanding of the receptive area is not that large grey shaded area, but the towns basically north of Townsville and Charters Towers along the coast. That's where you get sufficient vector density, humidity, and therefore rapid development of larvae and mosquitoes, and shorter extrinsic incubation periods, and longer survival of elderly females, all of which add up to a higher reproductive rate for the illness. If you look at the years recently, we've had an increasing number of dengue imports and outbreaks, mainly because of direct travel to neighbouring countries. And of course, throughout the tropics, dengue mosquitoes have exploded because of slum accommodation and rubbish and water holding practices where people don't have piped water and they've got to store it. All perfect for this slum mosquito. So we've been saying it's relatively unlikely we'll get a big Zika outbreak in North Queensland because North Queensland is pretty marginal territory for dengue. We don't get hyper-endemic transmission like we do in the favelas of Brazil or in places in Indonesia. We know that health promotion works. For example, in Mackay, we've got very few dengue mosquitoes and they don't get outbreaks. And we've been able most of the time to respond to dengue fever outbreaks and wipe out the virus. We're one of the only places on earth that can actually stop dengue outbreaks. And also when Zika was going through Southeast Asia and the Pacific, even though we weren't looking for it, it didn't seem to result in outbreaks here. And finally, the Eliminate Dengue project, which has been doing release studies to look at the maintenance in the population of these released bacteria-carrying strains, we have good evidence that it blocks Zika replication just as well as it blocks dengue replication. And that's probably been very fortuitous that those release experiments have happened in the high-risk areas of Cairns and Townsville. So, for example, here in Townsville, the grey area is all of the really old, junky, messy, older suburbs, and now soon they'll be moving over to newer suburbs, which are cleaner and therefore not so many breeding sites for Aedes aegypti. I've mentioned the Asian tiger mosquito, aggressive biter, can live in temperate climates, and also can be a Zika and dengue vector. We think probably this will eventually get into Australia. It's in every other continent, including the United States. It would complicate our vector control mission, and it would extend possibly the areas which could get these viruses. We may not be able to stop it, but certainly they've been pretty successful recently in the Torres Strait, wiping it out from Thursday Island, the capital, and the port. And so what we've learned recently from the dengue outbreak in the Torres Strait is that we do get dengue outbreaks on people moving between Papua New Guinea and the Australian islands. They are relatives of each other. But in the outer islands, it's mainly albopictus. And in the inner islands, it's mainly Aedes aegypti because we're working very hard there to eliminate Aedes albopictus. There's been a lot of concern in the rest of the country about exotic importations of mosquitoes, and although there's a long-term job to do about that, a handful of imported exotics in Sydney or Brisbane is not going to start an outbreak. This is just my favourite picture of epidemics. And so we do a lot of tracking, for example. We've got a network of traps across the suburbs of Townsville, collecting mosquitoes, looking at the numbers and the density at different times of year and relating that to risk. Of course, that also relates to which of those mosquitoes are the ones carrying the Wolbachia bacteria that renders them resistant to the viruses. I guess the big problem for North Queensland is that because 80% of cases are asymptomatic, and also those asymptomatic people still get viremia and thus are still able to transmit to mosquitoes, then we could have an outbreak without knowing it. We could have people silently spreading this disease throughout Cairns and Townsville suburbs, and we might only find out in 9 months. So the way we respond to dengue is that we rely on accurate notifications, mapping of where the mosquitoes are. Because they don't fly very far in their lifetime, we can kill them in that neighbourhood and stamp out an epidemic. But if we don't know where the cases are, we could have a very large Zika outbreak that we could not use dengue methods to control. So this is a little bit different to what I said earlier about you control the vector, you control the disease. Here we've got two different diseases from the same vector, and one method will work better for dengue than for Zika. So that's quite interesting. If we did have an outbreak, even if we announced only one local transmission, we would probably have a panic among pregnant women. There are about 3,600 pregnant women in North Queensland at any one time. And we're doing some hard thinking about what we would tell them and where we would send them and whether the lab could possibly do the amount of tests that people want or the ultrasounds or the obstetric services. Okay, so this is a response map, the kind of thing that we do for dengue or Zika incursions and imports. Around the known case, we will put up circles of about 100 up to 200 metres and do killing of mosquitoes in all of those properties if we can, as quickly as possible before those mosquitoes can develop the virus or grow a new generation of mosquitoes to bite their neighbours. And generally we do three things. We would do source reduction, getting rid of containers, helping people to remove breeding sites. We put in adult traps, which is egg-lay traps where an insecticide will kill those mosquitoes. and we'll spray inside people's homes with a residual insecticide. By the way, an old technique that was used for malaria for many years with DDT. This is with pyrethroids, which are very safe, and because these are indoor mosquitoes that like to hide indoors, if they don't survive long enough to go through one EIP, then the chances are that they won't be able to spread it to anybody else in the household. So this is the kind of health promotion that has been done in the past. Tip it, store it, throw it for anything holding water, and talking about what to get rid of dengue. So our key problem at the moment is that because this is largely an invisible disease and we think that the asymptomatics are able to spread it, I've given you another paper actually. So there are two papers that I put up. One was about causal criteria and the other one is by analogy, a difficult piece of research that showed that asymptomatic humans transmit dengue virus to mosquitoes. If the same applies for Zika, we might not be able to stop or detect an outbreak early enough to stop it, and therefore we really need to work on prevention. So rather than waiting for a Zika outbreak, which many of you imagine we're doing, we're actually working very, very hard to do prevention work, a vast expansion of what we do every year in terms of hotspots and known suspects and difficult areas and tourist areas, etc., trying to prevent an outbreak. And also working on testing and surveillance to see if we can detect the presence of the virus in our community sooner. Lots of health promotion work, trying to get the community to work, and now a focus on young mothers or reproductive age groups or pregnant women to try and protect them in particular. So if we get a very widespread outbreak, we won't be able to do focal treatments. It would have to be a citywide response. We don't have the staff to cover these very large suburbs with hundreds of thousands of people, and therefore we would need the community to work with us on a response. So one of the things we're doing is encouraging people to collaborate with the Eliminate Dengue trials. Here in Townsville, they're still finishing up half of the suburbs, and that'll take several more months. Our teams are stocking up, getting more resources. We've moved a lot of the public health unit resources into prevention, and we're looking at things like childcare centres and primary schools to spray them and protect those because that's where young mothers go. We know we don't have bulbactia mosquitoes in smaller towns, so we're focusing on them and working out all of the communications without trying to spread a panic. A lot of the stuff about vector control can be done at home if people understand what they're doing, and we need doctors to notify on suspicion. And we've given guidelines about how people should test, which would be more stringent or more sensitive, hopefully, than the concern elsewhere in Australia, where you're only really worried about imported cases and sexual transmissions. So we feel that not enough is being done in North Queensland, that the very small amounts of money that are being spent on this are not commensurate with the risk. If you think about lifelong care of dozens of damaged children and all of the concern that would be caused by an outbreak. As I mentioned, we can do things about getting rid of containers. We can ask people to use various anti-mosquito measures at home. We can give people advice on what to do during the daytime and mornings and evenings when this mosquito bites, including repellents and protective clothing. We know that diethyltoluamide, the best of the repellents, and pyrethroids, and methoprene, which is a larvicide insect growth regulator, are all safe in pregnancy. And also we've got very specific traps with small amounts of insecticide, very small amounts of insecticide in them, for trapping Aedes aegypti looking for water to lay their eggs, if we can trap them in those little containers of water. But probably the secret weapon is interior residual spray. As I mentioned, surface spray in dark hiding places around the house. When they studied a dengue outbreak in Cairns, they showed that when it was done by the spray teams, it protected occupants by about 90%. Of course, if we had a drug or vaccine that could protect 90% of people who used it, we'd be demonstrating in the streets to get it. There seems to be a systematic neglect of interventions which have high effectiveness but are not drugs. We've actually put up online, and you can see on the Queensland Health website, a how to do it, spray your own house video, and it's up on YouTube as well. So We've had a lot of problems with health promotion. This is done by people in Brisbane with very little understanding of our local problems. They just say avoid mosquitoes. It's a bit like saying avoid germs or something like tuberculosis or flu. Over many years there's been a bit of awareness of dengue and preventive actions built up in the community, but we still get blow-ins and locals who know nothing. And as I say, we're going to have to plan what to tell the community if there is an outbreak and how we can try to protect hundreds of pregnant women. So all of the things that you know about travel advice, we do. I have a reservation about travel advice that I'll come to, but high-risk settings, particularly for pregnant women. Down the bottom there is a thing called a road speed barrier. Now, throughout Australia, they fill these things up with water and leave them lying around in our streets to get people away from roadworks, which is really good, except that they breed mosquitoes in North Queensland and they're a really bad idea. And we've been trying for years to get them banned here, as well as a number of disposable containers, etc. The other thing that was bad in the health promotion is that they used a road sign logo with a mosquito on it, just like you'd look at a road sign of a wombat or a kangaroo. The problem is that locates the problem away from home. This is not a bush mosquito, it's a home mosquito. People imagine it's a bush mosquito we've already lost. And so our proposed logo is the one on the right, showing the mosquito where it actually lives inside your home. So it's really important here that we differentiate between ordinary mosquitoes in the bush and Aedes aegypti. Bush mosquitoes live in salt marshes and swamps and rivers. They're very strong flyers. You will get very large numbers of them flying into the suburbs, and you will notice the bites. They bite both humans and animals. They tend to stay outdoors, and they're noticeable because they're biting you in the evenings and at night. And people have some idea how to use repellent for them. Now, the problem with Aedes aegypti is that these things are breeding in and around your home. They don't move very far from your home. They're very shy. You might not even notice that they're biting you on the feet. They only bite humans. They try to get into your house, and they're not noticed. They will bite multiple humans in one go. Now, people don't use insect repellent inside the house, nor do they cover up their bodies. In fact, it's a false sense of security to use insect repellent for night-biting bush mosquitoes, and people are misdirected to think that they're protecting themselves from dengue mosquitoes. So we've tried to move well away from this idea that you can repel these mosquitoes. If you've got an Aedes aegypti in your home, it will try to bite you or die trying, and you can repel them or wear clothes as long as you like. They will eventually get you. So the message has to be to kill the mosquitoes, not to avoid bites. So these are the sorts of places that we're teaching people to avoid: old tyres, pot plant bases, neglected pools and boats. And this comment is about, these are the known areas where we can get dengue in the world. Not all of them are on the list of known outbreaks of Zika, but we have very poor information about the distribution of Zika because it's very mild, we don't have the diagnostics, or we don't have the surveillance of birth defects. So what I would like to be telling travellers, at least into North Queensland, is don't go to any country that can have dengue, never mind where we already know we've got outbreaks of Zika, because that's just the tip of the iceberg. So if you're pregnant or contemplating a pregnancy in the next month, don't go to the listed countries, but not to any endemic country for dengue, nor your sexual partners, and use safe sex throughout pregnancy if the male has been exposed. And again, he may not even know whether he was sick, because we know that semen may be positive for more than a couple of months. All of the stuff about mosquito avoidance is fine, particularly in countries that have got both vectors. We haven't. And using bed nets in the daytime, which trap and kill the mosquitoes because they're impregnated. We actually have to give guidance to doctors because unless we test a lot of people, we could miss the import or the first locally acquired cases. And so in Queensland, they're saying anybody who's been tested for dengue, we should also test for Zika. We're saying any of the arboviral syndromes like Ross River or Obama Forest or clusters of itchy rash, for example, might be an indicator that there's something going on and to look for Zika. So we're trying to be much more vigilant because it's so important to us in North Queensland. We know that if you look at this diagram, people only develop antibodies, IgM, a few days after they're symptom onset of fever, and there's probably another day where people are infectious even before they have symptoms with the viremia. We think it's exactly the same with dengue fever and Zika. In other words, if you're just testing for serology, you're missing it. You need to do the PCR early on. Blood, it may be there for up to a week. Urine, it may be there for a couple of weeks or more. So we're particularly suggesting urine and possibly even saliva PCR testing. So serology is very difficult. With dengue, we've also got serology for a viral protein called NS1, which can be very definitive. But the problem with serology is if you've had any of the other flaviviruses, including the Australian domestic flaviviruses in the past, then your body will primarily react with the old serotype or the old viral strain's IgM boost rather than the new one. It's called original antigenic sin. And so often you'll need two bloods, testing in parallel, neutralization tests, by which time there's very little chance to do anything, at least from a vector control point of view. So it's really important to test people while they're sick, if they're sick. So a lot of the work around vector control in North Queensland is just reducing all the delays and trying to respond very quickly and get the outbreak early. This is a picture showing a canary in a coal mine. I use this to describe the difference between case finding and surveillance. When the bird dies, everybody has to get out because there's carbon monoxide. They do not do this for the benefit of the canary. This is done to help other people. So if it's to help other people, that's surveillance. If it's to help that person, it's case finding. And we tend to mix those up pretty badly. So all sorts of surveillance is needed here. We need vector surveillance, including how many of them have got Wolbachia in the treated areas. Surveillance for the virus itself in the mosquitoes is probably too hard and the pickup is very poor. We tend to look for humans that are carrying the virus rather than mosquitoes. Vector competence I mentioned, and then disease surveillance. And again, a low index of suspicion to test enough people to not miss local transmission in our areas. And of course, surveillance for complications. At the moment, there's very few of them, but Australia is blessed with perinatal and obstetric surveillance systems so that you can bet that any kid born with microcephaly or similar syndromes will be tested for Zika. As I mentioned, clinically, you might see clusters of rash, which would be different to some other diseases. And we have databases for these notifications and mapping. And so a lot of add-on testing is being done by the Public Health Unit up here to try and pick up Zika earlier than we would have otherwise. If they're pregnant, we would have to refer them to obstetrics for confirmatory testing information, serial ultrasound, etc., though there's no cure. Partners of pregnant women need safe sex. Imported cases, also we need to make sure that they don't get bitten by local mosquitoes, and we would spray their house and their neighbours. And if we had a locally acquired case, we would have to declare an outbreak, even one, and might require a city-wide response. And of course, we would probably need to do some disaster planning if there was a set of pregnant refugees, for example, trying to get out of town. And I'm not sure that wouldn't be a bad idea. So we've really got to know our enemy, look at passive versus active controls. Passive controls are things that people don't have to think about and are generally more effective. Go after the specific vectors, get the cases early, and know what you're going to do for an outbreak response. Although we are not planning for an outbreak response for Zika, we're actually trying to make the environment more hostile in many, many different ways, and not just spraying, looking at characteristics of the built environment. So these are pictures of the various types of traps and sprays of people who could spray within their own houses with surface spray. So Zika is a game changer because it's milder disease, much harder to detect. We may not detect an outbreak early in Queensland, and that would be quite disastrous. And therefore we're doing a lot of prevention work rather than sitting around and waiting. And that's really not understood by authorities, unfortunately. I even saw in the MJA an editorial that said that we have well-established means of controlling dengue, therefore we can control Zika. I don't believe that. So this is the sort of advice that we would have for pregnant women. Try and avoid panicking or swamping the laboratories. Obviously, if there's a Zika outbreak, we would advise people on contraception, but until when is it difficult to know. Stay in a screened or air-conditioned house. We know that dengue disappeared from southern Queensland and northern New South Wales because of lawnmowers and piped water rather than anything that we were doing. Source reduction, that is getting rid of breeding sites, preferably in the whole neighbourhood. Being able to spray your own house is highly protective, and we're trying to hammer at that, as well as reassure people about the safety. And we know that the treated Wolbachia suburbs have a degree of protection. If all else fails, maybe people should be leaving town. So the good news and the bad news. Zika's probably not here, but we're not 100% sure. We've probably confirmed the link to birth defects. We've got a mild illness and therefore more difficult to control outbreaks because we can't find the cases, and therefore we need to do a lot more about prevention, including people spraying their own homes, because we just don't have the resources. The government is neglecting North Queensland, in my view, never mind the neglect of our neighbouring countries and poor countries, which are just basically on their own. So we're doing what vector control we can and trying to do surveillance for the virus to pick it up earlier. So here's some of the changes that I've mentioned. Rather than telling people to avoid mosquitoes, which is a misdirection, we're telling them to kill these mosquitoes. We don't want a road sign, we want a logo with the mosquito in your house. Rather than saying don't go to epidemic countries, we're saying don't go to any country that can get dengue. Rather than doing outbreak responses, we're doing outbreak prevention because we don't have the tools to stop Zika outbreaks. And rather than just relying on our own staff in a sort of a top-down way, we want the community to participate, and we're doing a lot of health promotion, at least what we're not funded for, to help people to do that themselves, and particularly focusing on places where pregnant women go, such as childcare centres. I guess one of my other gripes is that the surveillance systems are suited to the rest of Australia, but not to North Queensland, and so included in the national surveillance definitions is not whether or not they got the mosquito transmitted disease locally or whether it was an import. So they just talk about cases rather than imports versus local. And of course, differentiating sexual, vertical and vector-borne transmission would also be important. So that's the sort of stuff we need to act, and that's what surveillance definitions are for, not just to feed a computer in Canberra. So thank you. I don't know if there are any questions. Brittany, you might be able to help here.
Thank you for that great presentation, Dr. Donohue. That was very interesting. We do have a question. If you just want to open the chat function for me. And it says, you mentioned a couple of papers. Where can we access these?
If you go into sharing
So I've sent them through RICP. I'm not sure. I think you're going to put them up on the website. Is that right, Brittany?
Yes, so the meeting organiser does have these, and we will be providing those to people who email through, and if we can put them on the website, we'll do that as well.
Okay.
Does anybody else have any other questions for Dr. Donohue?
Perfect. So if you just bring up your presentation, you can just talk over your slides.
So yes, Peter, if you contact the AFPHM email, we will be able to send those through to you.
So we'll just get going. I'll just make sure that
no problem.
the room is ready to go. So just give me a couple minutes.
Was there any other questions while we have Dr. Donohue here?
Yes, perfect. Thank you.
Yeah, we're hearing, I think, another lecture in the background because you're working so close together.
Sorry about that. It doesn't look like we have any other questions at the moment, Dr. Donohue. I want to say thank you so much for your time, and we look forward to working with you again in the near future.
Thanks very much. Bye, everybody.
Thank you, everyone, for connecting this month. We'll see you next month for another great presentation.
Right.